Hi everyone, today's lesson for geometry is from Unit 3.2 Part 2, and today we are going to talk about graphing linear equations. So if you recall from Algebra 1, slope-intercept form of a linear equation is y equals mx plus b, where m is the slope, or what we should be calling it, the rate of change. And b is the y-intercept. Now, just a quick review of intercepts. The y-intercept is the point where the line crosses the y-axis. So if you think about a graph, and that's the y-axis, this is the x-axis. If this is a point where the line crosses the y-axis, then the x-coordinate would have to be 0. So you'd have 0, comma, whatever the y value was. The x-intercept is the point where the line would cross the x-axis. So if we had another line coming in here, and it crossed the x-axis at that point, that would be the x-intercept. So it would be x, comma, 0. So to find the y-intercept, you let x equal 0. To find the x-intercept, you do the opposite. You let y equal 0. So just reviewing the basics, we want to identify the slope and the y-intercept for each equation. So each of these is written in y equals mx plus b form, or slope-intercept form. So the number in front of x is our slope. So in a, the slope is 3, and the y-intercept is at -1. In part b, the slope is -1/2, and the y-intercept is +4. Again, think about what that means. It means that the line, the graph of the line, is going to cross the y-axis at +4. In the last case, part C, the slope is 2/3, but the y-intercept is 0. Notice we're not adding or subtracting anything at the end. So this means that this particular graph would go through the origin, or through the point 0, 0. All right, now let's practice some graphing. In number 2, it says graph each line using the slope and the y-intercept. The first thing we would like to do is put the y-axis. So draw a line right down the middle of your graph. Label that with the y-axis. And draw a horizontal line for the x-axis. And now we can start our graph. So in our equation, we have y equals 2/3 x minus 4. So that means the slope is 2/3, and the y-intercept is -4. So the y-intercept of -4, that means that our graph goes through the point 0, comma, -4. Again, y-intercept, it's a point where the graph crosses the y-axis. So come down to -4 on the y-axis and put a point. Now that's our starting point from the graph. Now we want to use the slope of 2/3 to get more points on the line. So it's a positive 2/3, so the rise is 2. So from that y-intercept come up 2, and then the run is +3. So go to the right 3 and put a point. And then you can connect those 2 points and make your line. Okay, you can check it. Check out the y-intercept, see that it's -4, which it is. Check out the slope, +2 over +3. Okay, let's try the next one. So again, let's put the y-axis on there. Put the x-axis on there. Let's identify the slope for this equation. So we have y equals -1/2 x plus 2. The slope is -1/2. The y-intercept is 2. Okay, start by plotting your y-intercept at +2. So come up 2 on the y-axis. The slope is -1/2. So we have 2 different things we can do with that slope. So we can, that's a crazy m. We can plot it as -1 over 2, or we can do +1 over -2. So starting at that y-intercept, if we want to use -1 over +2, you would come down 1. and then go to the right 2. Down 1 to the right 2. Or if you wanted to use this as your slope, say you ran out of room on your graph and you needed to go in the other direction, come back to your y-intercept. Now do a rise of positive 1, so go up 1, and then a run of negative 2, so left 2. You see how all of those points still are on the same line. Okay, use a ruler to draw your graphs, make them neater. Okay, let's see what's next. So one way of writing equations of lines is slope-intercept form, y equals mx plus b, and usually in that form the equation is a little bit easier to graph. We can also write equations in what's called standard form. And standard form is ax plus by equals c. The a, the b, and the c are all capitals, okay? A, b, and c must be integers. So sometimes I feel like this is kind of a more formal way to write the equation of a line. So the easiest way, very often, to graph lines that are written in this form, in standard form, is to use what is called an x-intercept and a y-intercept. Because we know that in order to draw a line, we only need 2 points on the line. So the x-intercept is 1 point, the y-intercept is another point. For example, we're going to graph the line 2x plus 4y equals 8 using the x-intercept and the y-intercept. So to find the x-intercept, remember that that's a point on the x-axis. Every point on the x-axis has a y value for 0. So what you're going to do in your equation is plug 0 in for y. So we'll have 2x plus 4 times 0 equals 8. So that's 2x plus 0 equals 8, or 2x equals 8, and that gives you x equals 4. So what this means is that our graph would cross the x-axis at 4, 0. See how that's a point? X value is 4, but the y value is 0 because it's on the x-axis. Okay, let's move this up a little bit. Now we need to find a second point, so we're going to find our y-intercept. So we do the opposite. We substitute 0 in for x this time and solve for y. So in our equation, we'll do 2 times 0 plus 4y equals 8. So we have 0 plus 4y equals 8, or 4y equals 8. When I divide by 4, that means that y is equal to 2. So this point is 0, 2. So our graph, our line, is going to cross the y-axis at positive 2. Okay. Now finally we're going to graph this line. So come down to the grid and go ahead and draw on your y-axis. And draw on your x-axis. Plot your x-intercept, which is 4, 0. So go to the origin, count to the right 4. 1, 2, 3, 4. So that point is 4, 0, the x-intercept. Now plot the y-intercept as 0, 2. So come up to positive 2. Remember that this is the y-axis, this is the x-axis. You have your 2 points, then use your ruler to connect them with a nice straight line. Finally, today we need to talk a little bit about horizontal and vertical lines. So if you would draw in your y-axis. I wrote an x, it's a y-axis. Draw on your x-axis. Let's see if I can label that one correctly. We'll just go ahead and do this one too. Okay, so horizontal lines. A horizontal line could look like this on our graph. And horizontal lines and vertical lines are kind of unique when it comes to writing their equations. If you take a look at this line, if we find some points on this line, for example, this would be 1, 3. This point would be 3, 3. This point would be negative 1, 3. Really, that's a 3. Okay, And let's say this point would be negative 3, comma 3. So the equation of this line would actually be y equals 3. And this is because every point on that line has a y value of positive 3. The slope of the line equals 0. So if you try to write it in slope-intercept form, you'd have y equals 0 times x plus 3, because 3 is the y-intercept, and that would simplify to just y equals 3. If we draw on another horizontal line, if I draw on this line way down here at the bottom, its equation would just simply be y equals negative 1, 2, 3, 4. Y equals negative 4. Again, every point on that line has a y value of negative 4. Finally, for vertical lines have a slope that's undefined. Okay, so m equals undefined. So these are the only lines whose equations can't be written in slope-intercept form, because we have nothing to plug into the equation in place of m. So if you take a look at my vertical line here, and we look at every point on that line, we have 2, 0 for that point. This guy would be 2, 1. This point would be 2, 2, and so on. Every point on that line has an x-coordinate of positive 2. So we would say the equation of the line is x equals 2. And that's it. So vertical lines, it's just x equals whatever the number is for every point on that line. So this little blue line that I just drew, its equation would be x equals negative 3. Okay, good luck on the homework.